last lecture PowerPoint. So because of this is basically the concluding discussion, we will talk about how one should evaluate and can evaluate other people's as well as your own research by using different kinds of validities. We talk about statistical conclusion validity, internal validity, external validity, and ecological validity to evaluate the quality of conclusion based on that many attributes of the study and how they are related in the subsequent slide.
So in this last lecture of PowerPoints, we talk about different kinds of validities. So the first one is something called statistical conclusion validities. Why do we need to be concerned about this is most of the time in your research, you rely some sort of statistical inferences. And in particular, what you try to conclude is something about population, but that's based on the sample. So therefore, you have to relate sample statistics to the population parameter. Therefore, the reasoning involves certain kinds of assumptions. So depends on whether you're using those assumptions appropriately. It's going to affect the validity of your conclusion. That's what's called statistical conclusion validity. There are three different kinds of ways in which statistical conclusion validity may be influenced. First one is whether your use of a particular statistical analysis is appropriate. Number two is whether the data collection, handling analysis, and interpretation is consistent with certain assumption required for the analysis. And number three is whether your reasoning based on the analysis is sound. So these three examples will be discussed in more detail using specific examples in the subsequent slide. So in addition to the specific examples of the three different kinds of ways in which statistical conclusion validities are undermined, which we discussed in the previous slide, we have more examples, specific examples for the first aspect, such as the use of inappropriate statistical analysis here. So the one concern is the measurement scale. If you are computing the mean based on ordinal scale, that's not appropriate. So that's why that undermines statistical conclusion validity. And the other kinds of thing is use of particular kind, use of inappropriate statistical technique that may undermine statistical conclusion validity. These examples are actually listed and discussed in this slide. So the number two is a violation of assumption or assumptions. The reason why this is important is the statistical reasonings requires or based on certain kinds of assumptions. If you violate the assumption, your conclusion is not valid. The first example is, for example, I hope you remember something called central limit theorem, which is basically when you do inferential statistics such as t-test, what you're believing is sampling distribution of the mean is normally distributed when your sample size is large enough, such as larger than 25. This means when you're running t-test with your sample size of 10, that's a violation of the central limit theorem. Therefore, you cannot rely on central limit theorem. Therefore, the conclusion based on your statistical analysis, such as t-test, is not valid. The second case is a careless use of one-tail test. The one-tail test is actually not recommended because the reason is there's still the possibility that you may get the opposite effect than the one that you expected. So therefore, and also sometimes what people do is just to make it easier to reject the null hypothesis, you use one-tail test. That's definitely the violation of the assumption. And the final one is, ideally, I think we talked about it somewhere. in the study that emphasize accurate description, such as correlation between different kinds of variables in the certain kinds of population. That requires your sample is actually representative. If it's not, even though you may get the correlation based on your sample, that may not generalize to the actual population. That's a problem.
And a good example of this is most of the statistics in your psychology textbooks are based on samples of college undergraduates, not of the actual whole population.
Yeah, that's right. So you really have to. So here's another last example that's actually stated. Sometimes you collect a sample, and maybe sample with large variability in income and happiness, but small variability in IQ. This is not really representative. So ideally you have to have representative sample that's whose variability in income, happiness, and also IQ is constrained by the reality in the population. Not should not be artificial in the sample. If it's artificially inflated or deflated in the sample, then the conclusion based on the sample doesn't generalize to the population.
Right.
Therefore, that's invalid. These are the kind of things that you need to be careful about. The third kind of violation of or things that undermine statistical conclusion validity is sort of lack of knowledge or inappropriate knowledge of the statistics that leads to inappropriate interpretation of the conclusion, such as this. Okay, sometimes when you fail to reject the null hypothesis, you can't actually claim that two means are the same. What you can claim is it's inconclusive.
Right.
If you study claiming two means are the same, that is actually it undermines. It's not a valid conclusion because you are ignoring or misinterpreting the statistical reasoning. Okay, or also claiming that variable x causes y, or vice versa based on the correlation analysis. That's also the violation of the statistical reasoning. Okay, so it's the reasoning process could be false or unsound. In that case, your conclusion is not valid. That's also the undermining the statistical conclusion validity. Okay.
Internal validity. Internal validity is most important when you are considering the validity of an experimental study, the conclusion of experimental studies. The goal of experimental study is to show particular kinds of cause produces a particular kinds of effect. As such, you manipulate and isolate and manipulate one variable, which is called the independent variable, try to see whether or not it results in a specific effect by looking at the dependent variables. So internal validity concerns whether or not the effect that you observe through a dependent variable is caused only by your manipulation of independent variable. If you have a lot of extraneous variables that may be affecting the dependent variables, this confidence decreases. That's the threat to internal validity on experiment. Okay, so internal validity is influenced by construct validities, independent variable, and also dependent variable. What's the construct validities of independent variable? That's you claim to manipulate a specific kinds of variable. But if your control of the independent variable is low, then you may be simultaneously changing multiple variables. Then the construct validity of independent variable is low because you are not manipulating not only what you claim to manipulate, but it's contaminated by something else. The same thing can be said by dependent variable. You claim to measure particular kinds of variable by dependent variable, but if the construct validity of dependent variable is low, you may be your dependent variable may be simultaneously affected by some other variables. External validity. External validity is about whether your finding generalized to target population. So for example, even though you claim to study about college students in general. If you're conducting a study only in a very selective college, then the sample included in your selective college students will not generalize to the overall college students population. Then in that case, your external validity is compromised or limited. We talk about external validity. External validity concerns particular kinds of generalization, namely whether or not your finding based on your particular sample generalized to the target population. So when you study, when your target is the general population, and if you study how people's mental health or the behavior works in about uh, among the general public based on uh, students taking psychology courses in college, the sample is not representative of the target population. Therefore, it's limited, has a limited external validity. External validity. External validity concerns generalizability of the finding based on your particular sample to the target population. Let's say your target population is overall college students. But if your study is only based on the college students or of a particularly selected college, such as Ivy League school, it may not generalize to the general college students. Therefore, it's limited in external validity. Here I listed, given that many psychological studies uses college students taking psychology courses, what would be the kind of specific concerns with respect to external validity of the study using the college students to the general public? So these are basically the age is younger, the money it tend to come from slightly higher socioeconomic status than general public, level of intelligence tend to be higher, and political tendency tend to be more liberal than average. So therefore, these things is going to affect people's response, and as such, this may not be the fraction of the larger general public in the U.S. Therefore, it limits the external validity.
So we have been discussing the generalizability of particular kinds of effects across different kinds of participants. Namely, the main concern is that whether or not a particular kinds of finding that's observed by the use of particular groups of college students generalize to different kinds of people. So here, so let's think about this. So how would you examine generalizability of a study with a particular groups of college students? So you can imagine that you find some effect with the UA students. You still have to examine whether or not the same effect can be observed with the different kinds of college students. So here you can incorporate the variable of college students in the part of experimental design. So now the question becomes whether or not the effect that you obtained with UA students remain the same across different groups of college students. So this means you are predicting no interaction, just the main effect. This means if there is an interaction, such as the condition, that's the independent variable of your interest, interact with the score, so that means it doesn't generalize. So I present these two different kinds of scenario using as an example. Okay, so here the graph of the figure, there are two of them. So the x-axis represents the main independent variable, which is operationalized as two different conditions of condition A and condition B. And then separate lines represent separate schools, like school X and school Y. And then Y axis represents the value or score in dependent variable, for example. So in the left side, the condition A and B. So the school Y, according to the school Y, there is no effect of the condition A and B. But for the school X, there is a positive effect from condition A to condition B according to school X. Therefore, there is an interaction. This means the effect of condition A to condition B doesn't generalize from school X to school Y, because that's only for school X. In the right side, there is a different kinds of interactions. In this case, whereas for the school X, the effect of the independent variable from condition A to condition B is negative. For the school Y, that's positive. So it's an opposite direction of the effect. So in both of these cases, this means the effect of independent variable as operationalized by condition difference between condition A and B doesn't generalize across different schools. One additional idea, which is same of the validity, is called ecological validity. This is somewhat similar to external validity, but it's slightly different. The external validity is concerned about whether or not the finding based on your study generalized to other people, but the finding is using the same study materials and the study design. On the other hand, ecological validities are concerned not about the people, but about the actual situation. This is extremely important in experimentation. By definition, experimentation, the important consideration and the gist of the experimentation is to create very, very controlled situation, right? To minimize the influence of extraneous variables. This naturally create very unnatural situation, because by definition, the more manipulation and control you apply to the study situation, the more artificial the situation becomes.
Right.
Because the most noisy situation is the real world. So this means, given the real world is noisy with a lot of extraneous variables influencing, this means the most controlled experiment is the most artificial situation. This means it's not ecologically valid.
Right.
So the more control you apply to the experimental situation, the more artificial the situation becomes. That means the lower the ecological validity is.
Right.
So this means, in case that you are concerned about the ecological validity of a particular experiment with extremely controlled experimental situations, you have to replicate it in, such as, for example, field experiment in the real world, or you have to conduct observational study about the same study, the same research question, and to see whether or not what you found in the experimental situation actually generalized to the real world. Because otherwise, what happens is you observe the effect, but when you actually bring it into the real world, it doesn't matter, because it's going to be washed out.
Right.
And it doesn't matter, and it's not meaningful, and it's not useful.
Right.
Okay.
Exactly.
Yeah, that's the concern.
So we talked about ecological validity, external validity, statistical conclusion validity. Okay, and when you look at a particular study, almost always without exception, the study has some limited validity in one or more aspects. Therefore, no single study is perfect. Therefore, replication is very important. And that's the solutions to the issues surrounding validity. And in particular, replication using different participants address external validity, and replication using different materials design of the studies or activity address internal validity and ecological validity. And then also uh, using different statistical analysis to get the same result, increases statistical conclusion validity. Okay, so this last point is very important. Sometimes student researchers use multiple analysis to get the desired conclusion. That's actually incorrect. That's not the right way. You have to make sure that regardless of the different analysis that you may employ, you should always get convergingly to the same conclusion for you to trust the validity of your conclusion. Okay. If you are getting the different results based on different kinds of analysis, some of them are wrong, or sometimes all of them are wrong. Okay, so therefore, it's important that regardless of the different analysis, you should convergingly get to the same results. Those results are very stable and consistent and reliable results. And finally, meta-analysis compare the different studies finding using statistical techniques to establish the consistency. So we talked about different kinds of validity, okay? And then the different kinds of research may emphasize or uh, emphasize the importance of different kinds of validity. So the one distinction that I would like to make here is the distinction between basic and applied research. Basic research typically addresses the fundamental theoretical questions about mental processes, and it tends to use experimental procedure, because the reason is most of the times what people are interested in is the causal relations between two or more variables. Okay, so that's the basic research. Applied research is different from basic research, such that often applied research use some theoretical understanding based on the basic research to find or to investigate solution about some practical problem. So, for example, there may be some theory about certain kinds of study strategy, like having multiple types of representation help people remember the content information of complex idea. So given that is the basic theoretical understanding based on the basic research, applied research may try to investigate whether adding a diagram in the high school science textbook actually improves students' retention of textbook content. So in this case, this is applied because it's not interested in why diagram works. We already know diagram works in memory or helps memory under some circumstances. But the interest is rather in the noisy real-world environment of a high school classroom. Students use those techniques in reliably kind of frequent way and effective way to improve actual performance in the classroom. Uh, Important concepts that I would like to emphasize are random sampling and random assignment. Both of them begin with a random, so people may get confused between them, but they are really different. And I would like to emphasize the difference, because these two different kinds of things affect different kinds of validity, and as such, it's important for different kinds of study. Random sampling influences external validity, because random sampling produces representative sample, so therefore it maximizes external validity by increasing the correspondence between the target population and then the sample of your choice. On the other hand, random assignment is typically practiced in the basic study, such as experiment, where the control is very important. Because random assignment with a sufficiently large sample tend to produces equal distribution of a similar kind of people across different conditions. So therefore, it tends to minimizes uh, extraneous variables because it produces similar group of people across two different conditions in which only one factor is manipulated. Therefore, I tend to increases internal validity. Given what we talked about random sampling and random assignments contribution to different aspects of validity, I would like you to think uh, which of random sampling and random assignments are relatively more important in applied or basic research. Of course, both of them are important, but there is a relative kind of weight differences in the importance between random assignment and random sampling to basic and applied research. So what is the answer to the question? So let's think about this. The basic research emphasizes the basic findings such as whether or not a particular kinds of causal relations exist between two or more variables. Therefore, most important is internal validity between the relation between two variables. Okay, what about external validity? External validity is important, but even if external validity is compromised, at least if you have internal validity, you have some conclusion about the relation between independent and dependent variable based on the sample that you choose, even though you don't know whether that's generalized to the target population. Whatever the sample represent is your population, and as long as you have high internal validity, you have a conclusion between cause and effect that's manipulated through independent variable and measured through dependent variable. So therefore, random assignment that increases internal validity is more important in the basic research. But on the other hand, when you look at applied research is more concerned about whether or not a particular theory can be applied to improve people's life, such as improving student study effectiveness in the classroom. And in the real world classroom, it's impossible to achieve high levels of control. That's why uh, random assignment is given up. It's kind of not practical to implement random assignment. However, what's important is the composition of the people in the classroom in which you are conducting this quasi-experimental applied research is representative of your target population. Okay, so therefore, in applied research, more important is a correspondence between your population, target population, and your sample. Therefore, random sampling is likely to be more important relatively in applied research than basic research. Conclusion, you should be aware the research conclusion or the conclusion based on a particular research needs to be evaluated based on different kinds of validities. And different types of research have different kinds of purposes. Therefore, different kinds of validity has important varying levels of importance. And control and random assignments are more important for basic research. On the other hand, in applied research, ecological validity of situations and then also the random sampling to increase the correspondence between the sample and population is more important. So you in a sense, so on the one hand, sometimes more importance is a control. And on the other hand, in some cases, it's not the control, but it's actually similarity between the target situations and the situation that you're producing in the study is important. So those are the kind of things that you cannot get both. So you need to really focus on one at a time. That's why multiple replication attempts with the different kinds of method is important.